Pop quiz. Which change can turn one element into a different element? Breaking a chemical bond, losing an electron, changing the number of protons, or melting a solid? Lock in your answer. We will reveal it soon. And by the end, this idea will feel a lot less mysterious. In this video, you will learn what makes a nucleus stable or unstable, how radioactive decay can change a nucleus, and how to read and balance simple nuclear equations. First, here is the key difference. In a chemical reaction, atoms get rearranged, but each element keeps its identity. In a nuclear reaction, something changes inside the nucleus. If the number of protons changes, the atom becomes a different element. To keep track of nuclei, we use nuclide symbols. The atomic number tells you how many protons are in the nucleus, and that decides the element. The mass number tells you the total number of protons and neutrons. Back to the pop quiz. The correct answer is changing the number of protons. That is what changes one element into another. Breaking bonds, losing electrons, or melting matter can change a substance's behavior, charge, or state, but they do not change the element itself. So, what makes a nucleus stable? A useful model is the band of stability. Light nuclei tend to be stable when protons and neutrons are present in roughly similar numbers. Heavier nuclei usually need extra neutrons because proton repulsion gets stronger as the nucleus gets bigger. Inside the nucleus, protons repel each other because they have the same charge. What keeps the nucleus together is the strong nuclear force. When the balance between attraction and repulsion is not right, the nucleus can become unstable and decay into something more stable. There are several common ways a nucleus can change. Alpha decay emits a helium nucleus. Beta- decay emits an electron. Positron emission emits a positron, which is like a positively charged electron. Gamma emission releases energy as very high energy light. Let's do one example. Radon 222 can undergo alpha decay to form polonium 218 and an alpha particle. Notice what happened. The mass number drops by 4 and the atomic number drops by 2 because an alpha particle contains 2 protons and 2 neutrons. A common mistake is to treat every emitted particle as if it changes the mass number. That is not true. In nuclear equations, an emitted electron has mass number 0. So beta- decay changes the atomic number but not the mass number. So far, we have covered what makes a reaction nuclear, why nuclear stability matters, and the 2 key balancing rules. Total mass number must match on both sides, and total atomic number must also match.
Want to lock this in? Your personalized practice test and flashcard set are all waiting for you. Tap the link and give yourself a quick check.
Now let's look at beta- decay. Carbon-14 can decay into nitrogen-14 by emitting an electron. In this process, a neutron in the nucleus changes into a proton. That raises the atomic number by 1, so carbon becomes nitrogen, while the mass number stays the same. In simple balancing examples, tiny neutrino particles are often left out. Positron emission, also called beta plus decay, goes the other way. Fluorine 18 can become oxygen 18 by emitting a positron. Here, a proton changes into a neutron. The atomic number goes down by 1, and the mass number stays the same. This helps when the nucleus has too many protons relative to neutrons. There is also an important edge case. In gamma emission, the nucleus releases energy, but does not change into a different element. Think of it as an excited nucleus calming down to a lower energy state. Let's solve one together. Sodium-22 emits a positron and forms an unknown nucleus. First, balance the mass number. Since the positron has mass number 0, the new nucleus must still have mass number 22. Next, balance the atomic number. Sodium has atomic number 11, and the positron has atomic number +1. So the product must have atomic number 10, which is neon. Here is a practical method for solving nuclear equations. First, identify the type of decay. Then update the mass number and atomic number using the matching rule. Alpha decay lowers both numbers. Beta minus decay raises the atomic number by 1. Positron emission lowers the atomic number by 1. Gamma emission does not change the element at all. To recap, nuclear changes happen in the nucleus, and the proton count determines the element. Nuclear stability depends on the balance between nuclear attraction, proton repulsion, and the neutron-to-proton ratio. Unstable nuclei can move toward greater stability through alpha decay, beta minus decay, positron emission, or gamma emission. To balance any nuclear equation, match both mass number and atomic number.
Ready to quiz yourself with the content covered in this video? Check out the link in the description, where you'll find Quizlet content made just for you.